right, conditional probability often applies when we fall into different categories. Conditional probability is sort of related to dependent events. It is the probability of an event happening given that another event has already occurred. We have a special notation for this. If I wanted to write the probability of event B happening given that A has already occurred. So event A is the first event, and then event B is the second event. We would write the conditional probability of B given A occurred. There's a formula below in this box, and it denotes the importance of the numerator will be both events occurring, and then the denominator is that first event occurring. Venn diagrams are used to aid in probability. We have intersections and unions, which represent and or. So when we have an intersection, it fulfills the overlap of the two events. So if you have a Venn diagram and you have event A and event B, and the overlap is the intersection here, and that's the and. The notation we use is a little hill. So an example would be we have jeans and pickles, so here's jeans and pickles, and that's the overlap. The second notation is union. Union refers to or. So if we have two events again, here's A and B, and we use the letter little u, and the notation is jeans or pickles. It is or. It fulfills one category or the other or both. So we can shade that area. So again, the two words are union and intersection and or. Example 1. Given this Venn diagram, it has been completed. There's two events that have occurred. There's event A and event B. And then the probabilities are given within the regions. So probability of A occurring, how you figure that out is you add everything in A together. So you'd add 0.4 plus 0.3. Not in A would be the 0.2 plus the 0.1. This now represents the probability of A and B, so that's the intersection. So that's going to be that overlap right in here. That's 0.3. The last one is union, which represents or. So you'd add up the 0.4, the 0.3, and the 0.2. To give you 0.9. Example 2. There are 500 students in a school. 150 students are enrolled in algebra. 80 students are enrolled in chemistry. There are 30 students that are enrolled in both algebra and chemistry. And then we have some probability questions. So we're going to set up a Venn diagram. So the first event, A, in my circle is going to represent algebra. And this entire circle right here, all of A has to add up to 150. Then we have event B, our chemistry students. There are 80 students in chemistry, so that entire circle has to add up to 80. Then they give us that 30 students are in both algebra and chemistry. So that's the overlap right in here. So that number, if I erase the colors here, this number has to be 30. So we're going to go ahead and complete the rest of the Venn diagram. So we said this entire circle has to be 150, and we already have 30 left inside. So we would, to get this piece here, we would take 150 minus 30. So 120 students are just taking algebra. Then this circle here, we said, has to be total up 100 or total up 80. So you take 80 minus 30 that are already there, and you get 50. So that represents just students who are taking chemistry. Now the two circles, the green, the red, and the purple, those add up to the two classes. And then there are students who aren't in either of those classes. So they're going to go outside the Venn diagram. And that entire Venn diagram has to add up to 500. So we have a number outside the circle. So we take 500. And then we subtract the 120, the 30, and the 50. And what's left is 300 students. So this represents 300 students aren't taking either of those classes. Now we can go ahead and answer our probability questions. It says, what is the probability if you randomly select a student that they are taking algebra? So we add up the 120 and the 30, which is 150, divided by the total of 500. And you get 0.30. What is it probably that you select a student and they are taking chemistry given that the student is also in algebra? So this is a conditional probability. So the probability of chemistry given that they also took algebra. So we're going to set up our conditional probability. So we have our formula. We take the probability of chem and algebra in the numerator divided by the probability of algebra. So chemistry and algebra is that overlap, 30 out of 500. And then in the denominator, just algebra. That's this entire circle, 150 out of 500. And then we would reduce. We get 0.06 divided by 0.3, which reduces to 0.2. So you have a 20% chance. What is the probability that a student is taking algebra given they also took chemistry? So another conditional probability. So we set up our conditional probability, and notice the order is opposite. So algebra, and then chem has been given. So again, in the numerator, it's a probability of algebra and chemistry, the overlap, divided by the probability of the given chemistry. So the overlap is still the same as the one above, so 30 out of 500. And then probability of chemistry is both of those numbers right there, 80 out of 500. And then we reduce, so 0.06 divided by 0.16, which is 0.375. Example 3. Out of 50 students, 19 students are taking English, Comp, and 34 are taking Chemistry. 5 students are taking both. So we have English will be our event A, and then Chemistry is event B. And then we have the overlap, which is both. So I'm going to start with the overlap, 5. And then this entire circle has to add up to 19. So what's left? 19 minus 5 is 14. And then the red circle has to add up to 34. Well, 5 are already in this circle. So what's left is 29. And then the entire Venn diagram has to add up to 50. So what we do is we subtract 50 minus 14 minus 5 minus 29, giving you 2 left. So probability of a student randomly chosen is in English. So English is this entire circle, so 19 out of 50. The second part says the probability of English or Chemistry. So we would add up the probability of English plus the probability of Chemistry, and then we have to subtract out the overlap, the probability of English and Chemistry. So here's our English, 19 out of 50. And then we have our Chemistry, 34 out of 50. And then we have the overlap because we don't want to count those students twice. So minus 5 out of 50. And that reduces to an answer of 24/25. The last part says we have our conditional probability. The probability of Chemistry given English occurred. That's our given. So we set up our formula. So the probability of Chem and English divided by the probability of English. So we have Chem and English right here. That's that 5 out of 50. And the probability of English, the purple circle, 19 out of 50. And then we reduce, and we will get 5/19. Notice what happens. The 50 and the 50 just cancel out.